Hello everyone. So the idea behind this video is to do some investigation about scheduled tasks, and we see tasks get scheduled a lot, especially by ransomware. And the reason why they do that is, for example, either to delete the volume shadow copy so that way you can't, let's say, restore your system, or they will modify the boot configuration, so also they do a couple of changes there, etc. So there are many different reasons why ransomware will do a scheduled task. Plus, at the end, a threat actor also could use a scheduled task for persistence. Now, there are a lot of, I would say, good resources out there. I will show at least one, which in my opinion was a really good resource at the end of this video, and also refer to the Microsoft's documentation for scheduled tasks. But let's go ahead and at least understand first some of the things that are already out there, people have already explained, and then I will add the part where I didn't see in other, let's say, videos or in other blog posts, people referring to it. It might be that I didn't find that, so I'm not going to say I'm the one who found this, but at least I will say I didn't find the other piece which I'm going to show in this video. So first thing, by the way, scheduled tasks, once you have a scheduled task, you will find them located under System 32, especially on a Windows system, and then under tasks. And you can see actually they are normal files. They are like an XML file if we just open them. So if we open one with a text editor, we can see they are just like a normal text file. Now this is what people know about scheduled tasks. And if we bring also the task scheduler, so we can see what are the tasks available here, the name of the task, it's the status, what does it trigger, when will it next run, last run result, who's the author, when was it created, etc. So you can use this also to understand about a task. And you can see, once you click on a task, you can see the triggers, what are, and excuse me, you can even update them, like if you want to know what triggers are. So these are general details about the user, who's the user going to be running this task, etc. If we go to triggers, and let's say we want to add another trigger, so you can click new, and then you can see on schedule or maybe on log on. So once this user logs on, this task will run. Similar to things I would say that you see on PowerPoint, like the trigger, especially the animation when, for example, if you do a mouse click, it will do something. If you move your mouse, it will do something. This is similar to that, the triggers. So these depend on how do you want to trigger this task to happen. The actions, what do you want to run? So here, this is a scheduled task to run the NPP cap. So that's what it does. You can actually say new and then go start your program, send an email. It's deprecated, but anyway, for start the program, you can do that. Go browse to the specified path, and if you have any arguments, you need to specify here. Conditions, you can say what are the conditions. Settings, we can see all of these settings. I'm not going to go in all of these because that's not the point of this video, but at least you can see this is where this line can all be modified and done. Now what we are going to do, so you can see here, these are this is the date when it was created, the author, the user, the name of the task, and then a lot of other details, when does it start, etc. Okay, so we'll get into this, and you can see the exec, the command, when will this be executed. So now what we want to do is I want to replicate what a threat actor might do through a ransomware. So I'm going to replicate actually tasks which were done by a ransomware called Krylock. But again, there are other ransomware which will use similar tasks, so it's not a big deal which ransomware we are talking about. The idea here is to understand where are we going to investigate all of this. So now we have these XML files, that's one. So we know that's here. But I also want to show you that the other thing, which I think, as I said, I didn't find them in other blog posts, but let's go together and see where we can find them. So if we go to HKLM, Hive Key Local Machine, Software, and then go to Microsoft, and then go down to Windows NT, current version, and then go down to schedule. Schedule, okay. So here we'll find all the details about scheduled tasks, by the way. So if we go to task cache, okay, under here, task cache, we can see that, let me drop down this because it's a shorter tree, and you can see these are all the trees, all the, the scheduled tasks available on the system. Okay, so you can see the PCAP, dog, watchdog, etc. All of these, the OneDrive, etc. Now the Microsoft, it has a list of tasks, and if we go back here, by the way, and we say Microsoft Windows, then we'll see all of these under here. So that's why you'll see even in the XML file, if I go back here again, and let me open one of these just so we can see that. If we say open with, open, you can see the URI, it will show, maybe it's not listed here, or I am not looking correctly. Yeah, but it should show that under the, yeah, here, see the URI. So Microsoft Windows, and then application ID, and then this is under the application ID. Okay, so this is the policy converter, which was under the application ID. So the full path will be in the URI. So let's just go back here for now. So the thing is, these tasks, all of them, let's focus on these, not the Microsoft ones. All of these tasks will be created under tree. So that's why I said I didn't see another blog post talking about task cache. So I'm going to add here, for just a favorite, so I can easily navigate here. And we can see here all of the tasks are listed down here. Now each one of these will have what? Will have the starting date. I think that's what the SD is. We can check that, scheduled tasks, and say create, and then so we can see based on this. Let me expand this actually. And yep. So we can see based on this, it's the starting date, but again, it could be wrong. I didn't do a lot of investigation in terms of the data itself. Some of them are well known, or I would say were easy to understand, but some of them I still haven't done that yet. So anyway, start date, I assume this is a date, and the ID, which is the most important one for us. So if I copy this ID, okay, if I just copy this, and then what did I do? I didn't want to edit that. So if I go now to the tasks, you can see each task has like a GUID or an ID, and if we search here, we can find the details about this task. Okay, so let's replicate what a threat actor will do by running a specific task. So I already have that copied out from a case which was a ransomware case. So here we have the scheduled task. This was exactly what was the ransomware doing. We have the create option, and then we have the run as user. So we are running it as system, and the schedule is to be run once. The task name, which is the VSS data restore. Now this is to force it to be run. This is the run level, and it's either limited or highest. Here they specified highest. The task run, or the task to be run, and here the task to be run is this VSS admin delete shadows all quiet. And then the starting time is 00, and that's when this task could be scheduled. So usually threat actors, they use the 0000 because they don't know when your what time is the victim system running in now. and they have another method, or let's say another way of actually triggering this. So they will first run this. So this will successfully create the task. So we can see the task has been successfully created. And then what they do after that is they run the task. So what will happen is the task will be run through another command immediately after that. So here again, schedule task, we want to run, and we want to run the task name, which is the VSS data store, which we specified over here. So that's how, see, the task now has been actually executed. So if there were any volume shadow copies on the system, now they have been deleted because we run it that way. Okay, so this is one way the malware or the ransomware will do this. Okay, so if we go back here to our tasks, now we can see we have another file. If we open it, open with and notepad, we can see the details about this. We can see the author, the command, sorry. So the command, we can see the arguments which were passed to the command. We can see the author. Where is the, yeah. When will this task start? So that's when it will start. And again, as you can see, that's because let's say the threat actor does not know when to start this. What else can we see here? The author, the user who created the task, so here. And we see when was this task actually created. So it was created at this exact time. And these time are in the 24-hour time format. So that's why you can see here 14:29 and my time is 2:31 because it was just run maybe a minute or 2 minutes ago, less than 2 minutes ago. Okay, we can see the path. It's directly under the direct under the task directory. So VSS data restore. Okay, so let's go and now check the registry again. So if we go down here now and do refresh, we can see the VSS data restore got created, and we can see the ID of this VSS data restore. So if we copy that and now go, for example, here, just so we can search quickly for this, we'll see the ID and the entry. So we can see here the actions which were supposed to be taken. The author of, we will open this in another tool, but for now I'm just going to go over this quickly. The author, the date, when was this created, we already saw that in the XML file. Dynamic info, I still have no idea what that is. This is a hash value, probably to check if it has been modified. The path, the schema, I still have no idea what this is. What is going to be triggered, this is what will be triggered. We'll see that in another tool. And the URI, again, we will the full path to this task. Now let's bring Eric Zimmerman's tool, Registry Explorer, and let's look at the details in Registry Explorer. I highly recommend this tool. It's one of the best when dealing with registries, plus the other tool which is by Harlan Carvey, RegRipper. Now, the reason here we can load a live system, that's one of the reasons why I'm going to use this. So live system software, now it load the software. And let's just wait a little bit. This is loading the software Hive live on the system while the system is running. And if we go here, we can see we have a couple of bookmarks. Now, one thing which is not still available, I will ask Eric to push this for people to do later investigations, is add the like a bookmark for the tasks key. So if we go root and if we go to Microsoft, actually I will add it here and maybe push it later myself. So add Microsoft, and then we go to Windows NT, current version, go to schedule. So if we go to schedule, we go to task cache again. Let's add for task cache a bookmark so we can easily come back. So I'm going to go right click and then here. So I'm going to do, maybe it's an operating system, program execution. I'm going to put this under operating system. If Eric decides otherwise, he can change that. And I'm going to call this task cache and save. You can add a description. So now here we'll have the task cache. So whenever we load a software hive, we can immediately come back to this. Okay, so if we go now to tree, we can see a couple of things. So one thing which is very interesting, the VSS data restore, you can see the last written timestamp. So this is the last written timestamp of, see this one, of this VSS data restore. And I think the reason why it's showing us 1929 is because of the time zone. So this is showing in local time probably, or maybe this is local time and this is in UTC. I think this Eric has all his tools in UTC. So I think this is my local time, yeah, and this is in UTC. Okay, so keep that in mind. Now, the other thing here is we can see the ID. So if we copy that again, and now go to the tasks here, and just run a search quickly. So we are searching for the key name. We can see the task now if we open it, and we can see the details of the task. So we can see the path, where this path is located. Did I open something different? Because it looks like, wait a minute. So let me double check, what was I clicking on? Maybe I wasn't clicking on this one. Yeah, let's search again. So yeah, I think I wasn't searching for this task. This ends with CC0. Okay, so let's go back here quickly and do, okay, search. So we find that. The one under plain, by the way, just in case you noticed that one of them was empty. So the one under this plain, you'll find it empty. I don't know why. Again, this is still new, and I'm investigating this. But here under the tasks, you'll see the details of the task. So you'll see the VSS, the path, the hash value, the schema. Again, I don't know what this is yet. When was this created, the user or the author, the URI for this task, and then what is this going to be triggering. So these are different triggers. I think this is a binary format. Someone might need to take this out and parse it to understand what each one of them are doing, because if you recall from here, there are lots of triggers that could be added. So there are so many triggers that could be added. So we'll need to understand the binary format of this if we want to go in that direction. The actions to be taken, so we can see here, the actions to be taken is this VSS admin, and then delete, and then shadows, then all, then we can see the quiet to be done. So those are the actions. Dynamic info, I have no idea what this is, but at least, as I said, now we can investigate this. Now, why are we doing this? So now we have another location for evidence about tasks. So if, let's say, for example, the threat actor was able to delete this file, so let's delete that, and let's unload the hives. By the way, if you unload the hive and reload it again now, it will load the cached value. So I don't recommend you do that. Probably it's a way Eric does this to make sure the hive is loaded faster. But for testing purposes, when you want a clean, let's say, image or a clean snapshot of the hive, I would recommend to close the tool and run it again. So now we deleted the file from here, right? And if we go to this entry, so see the entry of the volume shadow copy, or sorry, the task, you can see it's still there in the registry. Even see, it's still there. Even if I do a refresh, it's still there. So even if, let's say, the threat actor managed to create a task and delete that, so the threat actor managed to come here and delete the file, we can still investigate that and understand what tasks were running on the system, because they are actually in the registry. Let's do one more final test here, just a basic test. And in this test, what I will be doing is similar task, but this time I'm gonna running a calculator. So again, it's just a similar task. Here we are running with user. So the only thing I changed here is user 1 and run once, and the name of the task, run calc, highest on the path, and then this. So we have this now. We can here just say run calc, and now we are running the calc. So you can see the calc has actually been executed. Okay, so let's go to the tasks directory. We can see we have the run calc. Let's open this again. And we can see when was this created. We can see the details, when this will be triggered. Excuse me. Little bit of water. We can see here the command to be executed, etc. So all of these are found in the XML file. And if we refresh this, we'll also see the run calc, the details about this. But again, what will happen if the user comes and, let's say, or the threat actor comes and deletes this? Before I do that, actually, let me run the Registry Explorer again, so we can go and check this. So Registry Explorer and live software. And now if I go to user created, so we can go quickly to this. We can see 3. So we have the run calc, and this is the ID of the run calc. So now we know the ID for the run calc. We can go to the tasks and search for it. So we can search. Okay, not this one, the one in the plane, it's empty, but we'll get the other one. So we can see the user, we can see the hash value for this, the schema. Again, I don't know what this is, the date, when was this actually created, the author, the task URI, name, the triggers, what will be triggered. So we can see these are what's gonna happen. Probably if we change them, this will be different. And I'm gonna do one check here. So author here and the task. So we can see here, this is the task to be executed. And then dynamic info, again, I don't know what that is, at least for now. I want to do one thing here, so I'm gonna copy the data, this data, and what I'm gonna do is notepad. I just want to check what's gonna change. The hash value, I'm sure this is for when things get modified. And I also want to copy the data here. I know this is not the best way to do it, but I just want to have an idea. Again, this is an experimentation. I just wanted to play with. So let's go back, unload this. Unload all hives, yes, and let me close this so that next time we get a new snapshot. Let me go here and let me just modify, let's say, the triggers. So one time, let me edit this, and let's say on schedule, on start, on idle, on workstation lock. Yeah, let's do on idle to change idle condition, use conditions pages in the create task or task probably. Or actually let's do on schedule, but let's say repeat this every 5 minutes. I'll just have to like daily record every 1 day, stop all running tasks and end of repetition duration, longer 3 days, expire. I'm just gonna go with this. Actually, I don't know what this is, or at least I'm not. It's gonna run every day, every 5 minutes, but anyway, let's do this. I just want to see the changes which will happen. So I'm assuming now this is scheduled. So let's get the Registry Explorer again and look at let's load the live software. And let's go to our task. Again, task cache 3. Let's get the run calc. So here, I'm sure nothing has changed. Let's get the ID. And then in tasks, let's search for this ID. So we can find it here. So let me get this and see if actually this has changed, because I assume it has changed, but we never know. Let's see. Yep. So now this also shows that the hash value will change based on what actions we do. So if we check the triggers, I'm assuming this one will also change. And if we get that here, so we do, yeah, the calculator started, and I can see, for example, here it was C09301. Here it became 10.0.94 01, then 05. Again, these are all, I would say these all need investigation to understand the time format for this, but this was just like to prove the idea of all of this. So again, we can see these also, by the way, these entries will also help us to understand when was this actually task. I know this only shows the last written timestamp, but still it's good to understand if there were any changes to this, because usually let's say a ransomware will run it, schedule it, and then it will just keep running. So it's good to have an understanding of that. And again, now if we, for example, let me do unload all of them, and if let's say the threat actor comes here and deletes this, so no longer available, and let's delete. Let's yep, let's close, run again, and yes. So in the registry, if we do refresh, so the run calc is still there. Like I said, VSS is still there, even though they were deleted, but we can still find them over here. And now if we go to load live software, let's wait a little bit. Okay, and then if we go to our bookmark and tasks and go over here, so we can go to tree, run calc, or the VSS shadow. Again, these are all still here on the system, even though they were deleted, so we can still find them on the system. And as you can see here, I can still know what happened on the system and when did this happen. Okay, so we can see all of those details through the Windows registry. So again, like I said, I did see lots of good blog posts, but they were mostly focusing on the scheduler. They were focusing on the XML file, etc. So now I'm adding the registry, so we can now reuse the registry and these tasks for our investigations and understand when and who and how a specific, let's say, action was triggered. You can, by the way, especially here, because we are talking about what's going to be what the action is. So here it's volume shadow copies. We'll need to correlate this with other evidence to understand even more about this. So it's good also to not take this by its own and look at it by its own. It's still good, but I mean, adding it with other evidence and stacking those up will help your investigation and give you a better time frame or timeline about what happened and by who, etc. So that's what I was wanting to show you through this video. The blog post, which I highly recommend you check, is the blog post written by Samir. I highly recommend you check his post. He has a lot of details about threat hunting, scheduled tasks for persistence and or remote execution. See, lots of details. That's how Samir does all of his work. All of them are highlighted with lots of examples. So I think even as you can see here, you can see the event IDs. I didn't go into that actually. Because actually I also saw a case where there were no event IDs. I'm not sure how that happened, but I'll get into that later. But at least for now, you can see what are the event IDs that you are used to create a task, to delete a task. Samir has all that listed. You can see also the Splunk query that you could use to detect this. This is if your, let's say, sysmon details or your event details is actually being thrown into Splunk. So I would highly recommend you check all of these. Like you see, lots of examples by Samir. Again, mine is actually just an add-on probably to this. And yeah, that was what I wanted to show. Also check the schedule, the scheduled task.exe, the Microsoft document, because you'll see a lot of also details about how to run the task. The tasks that I did were actually taken exactly as they are from the ransomware, which I was working on, or let's say playing with, whatever you want to call it. And I just did one single modification or two of them to create the calc task. But if you want to create other tasks for testing purposes, I would say check this page because also it has a lot of that details. So yeah, that's it for this video. I hope it added something, some value to your investigation. If you have any comments or notes, or if you know, by the way, for example, what is this dynamic info? I didn't find that. Or what the schema is. I saw that the schema is always this number, but I don't know what that is. So if you know what those are, have an idea, or if you have even a, let's say, a parser for this blob, binary blob, feel free to add and comment. I will add it to the blog, to this video, and that way we can share it with everyone else. So yeah, that's it for this video. I hope you enjoy your day, weekend, holiday, whatever you are doing today, and see you in the next video. Bye.